Thank you all for being here today and for your interest in the topic of today, the adoption barriers for design of experiments. I am Debbie van de Vijver. I'm co-founder of FX SaaS software for design of experiments. And with me today also is Peter Goos, also co-founder and professor at KU Leuven in statistics. This webinar is the fourth in a series on how to experiment more efficiently with design of experiments. And today we'll just go indeed deeper on those adoption barriers, on why design of experiments is still rather underutilized. And if you would like more information after this webinar, then please feel free to reach out. So today we'll have a couple of topics that we'll touch upon. One of those topics is design of experiments itself, on knowing that design of experiments exist, also on understanding the consequences of not doing design of experiments, having a culture for measurement, support from management, software, and that design of experiments is perceived to be very expensive. And we'll dig deeper on every one of those topics. First of all is on not knowing that design of experiments exist. We know today that because design of experiments is not broadly taught in schools, that many scientists or engineers are not really aware always of the methodology. And this is a real problem because that means that in a lot of companies that they are missing out on great opportunities to optimize those products and processes. And I think, Peter, if I'm right, you teach design of experiments at university, that you can only agree?
Sure. I'm one of those lucky people who can teach design of experiments at university in the Faculty of Bioscience Engineering of the University of Leuven. There's plenty of space to talk about design of experiments, so I do that using the book that I wrote together with Bradley Jones, who's in the audience today. And for the students, it's actually their favorite statistics course. So if DoE would be taught, it would probably be loved by many. But unfortunately, in many engineering faculties, design of experiments is completely ignored. And unfortunately, on top of that, if there is some room for design of experiments, then it's, I would say, often the wrong type of design of experiments that's being taught. Very often, the emphasis is on the very classical DoE, as it was invented for agricultural experimentation a very long time ago. But that's not the kind of DoE that's useful for the majority of the engineers. So I would plead for a more modern type of DoE course, for example, based on the book that I wrote together with Brad. And I think that would become immediately much more useful and immediately much more loved by the students. Having said that, it's not just the university's fault, I think, that DoE is rather unknown or not sufficiently well taught. I would say it's also partly due to consultants who often use a one-size-fits-all for their courses, and they often focus on the older types of DoEs, which are not always equally useful. I think a more modern source for the DoE courses taught by consultants would also help tremendously.
Thank you very much already. And I think other things that are also part of course, design of experiments is a very difficult lexicon. You have to really understand and know. I see a lot of the things that we do in consultancy is making the translation from industry-specific language to actually the statistical language. And we also see, unfortunately, today that statistics, if you talk about it, it's not a very sexy and hot topic. I think people rather like design of artificial intelligence or data acquisitions. And I think that's also like something that is there for the field of design of experiments and statistics to make itself a little bit more sexy and to make sure that it's known not only by academics, but also more known in other areas of expertise, like, for instance, the data engineers and the data scientists. The second part that we want to discuss is design of experiments itself. I think, Peter, that you can agree that it's sometimes feels really intuitive and that it really requires some knowledge of statistics to collect the fruits of design of experiments, that you haven't conducted?
Yeah, being in the field myself for more than 20 years, I've often wondered why design of experiments is not more popular than it is today. I think, first of all, there's a certain inherent difficulty in DOE, and that inherent difficulty stems from the fact that for design of experiments, you change multiple factors at the same time. That sounds scary to many engineers because it seems to give rise to very messy data. But actually, the data you get from a DOE are very well structured, and the data lend themselves very well to a statistical technique called multiple linear regression, which is perfectly capable of disentangling all the effects that you are willing to study and to quantify. The problem with multiple linear regression is that it's not taught in most engineering curricula. So there's another of these statistical techniques which is unknown and thus unloved. So a little bit more statistics or better statistics in engineering curricula would help here also to promote the use of DOE. Second thing about DOE, which makes it a bit unpopular, is that it costs an effort to do it. DOE is about collecting data, collecting new data, and that has a certain cost in it. And also it requires a major planning effort to carry out a DOE properly. What's more popular is one factor at a time. That requires less planning, that requires no statistics knowledge. Unfortunately, it leads to suboptimal decision making. So yeah, the difficulty that you change multiple factors at the same time and that you need a more advanced statistical technique is not, in favor of the use of DOE.
Thank you so much. Now, it's also important to understand for people like what are the consequences of not doing design of experiments. And of course, as FX, we often come across still companies that discuss whether there is the necessity of doing design of experiments, because of course, it's not that they do not do any experimentation. Of course, they conduct experimentation, but we know that for a fact that if you do not do design of experiments, then you basically rely heavily on the product and process expertise of individuals. And of course, these individuals have most of the time have already like a lot of years of very thorough expertise. When those people leave the company, there's no very structured way or why or how those data has been collected or why certain ingredients have been added or something. I think Peter has a nice example of that later on. And it also may take you a very long time to identify those critical parameters or robust operating regions. Now you might know from gut feeling or from some experiments that you have done that somewhere where your product properties are or where your operating regions might be, like for instance temperature or conveyor belt speed or like how long something has to be mixed, but you do not have the real data and the real causality. And that's then a third part, that there is no certainty on the knowledge discovery due to the lack of causality if you do not use design of experiments. And that's the beauty of design of experiments, that it does not only show you correlations, but shows you also the causality, and can know for a fact which are the parameters or input factors or whatever lexicon that you used, how they when combined, how they interact with each other, and how much effect that it can have on the product properties of your end result. And the last thing is, of course, that you also have no replicability of transferable knowledge, namely that, of course, it can be that some experiment went well somewhere in the past, but you cannot be sure that it will be when you redo the experiment, that it's the same, and to be sure that when you do the same experiments, you have the same kind of results is, of course, very important to have a robust operating process and to make sure that you have the same kind of quality and results every time again. And the thing is that, of course, we always work with humans, and that expert knowledge is always important, but it might also be biased knowledge, and you cannot undo bias. Of course, because if you have been in a company for a very long time and you know how things have been done, then you might have the feeling like, yeah, this cannot change. And the benefit of doing design of experiments is that it kind of eliminates part of that bias and gives you new insights that otherwise you might not have gotten or have found. And I think we had this really interesting experiment, Peter, with a company where they also were a little bit reluctant on design of experiments, but when they finally did it because there was no other way to find out what happened, that they were really happy and saw what was the benefit of it.
So what was happening is that there was an industrial bakery that had a certain product with a certain success. And that product involved a lot of additives that had been added over the years. And yeah, after all these years, they even don't remember anymore why all these additives are there. And now the customer doesn't want these additives anymore. The company wants to move to a so-called clean label product. And yeah, to do that, they don't have the right knowledge, they don't have the right data. They all only relied on, say, subject matter experts. And now that they have this force to move to clean label products, they are sort of in trouble. Fortunately, they have rediscovered or they have discovered DoE. So they're now tackling the problem with DoE, trying to move to so-called clean label products.
Another part that's very important to have in your company when you want to install design of experiments is having a culture for measurement. And I think that's what we sometimes see is that when talking to companies, that one of the most difficult parts of design of experiments is, or experimentation as such, is collecting indeed the data. Where is all the data being stored? Who is the one that has the specific data? Where is it in certain business units? And the thing is that having this culture for measurement really is a very important approach that offers a multitude of benefits, and of course is very important to be installed top down, because data-driven decision making, of course, embracing measurements encourages also this data collection and analysis, and it enables you to make informed decisions and based on real evidence instead of assumptions. And it also helps you to do continuous improvement, because if you have these measured outcomes of these experiments, then your team can really pinpoint the areas for enhancement and really then define and refine the design, but also the experiment to achieve even better results over time. Another thing that's very important when you have this kind of culture for measurement is that you can do real resource optimization. And with resource optimization, we're thinking today also when we're thinking about energy or trying to reduce waste, or also be more careful with raw materials because everything is also becoming way more expensive. Then the fact that you do these measurements helps you also to get to those desired results, with allowing very effective resource allocation. And knowledge sharing, of course, is also very important. And we have already talked a little bit about it on the previous topic on understanding the consequences of not doing design of experiments, but also this culture for measurement helps you really sharing findings and foster a culture of learning and knowledge exchange, and it empowers others also to leverage their past and future experiments beyond the existing knowledge today. So to have this culture of measurement and to really be capable of in a sense, unbiased discussing the results helps you to really foster innovation as well. And of course, a very important part of measuring is, of course, risk management and quality management, because through measurements also your team can evaluate, on the one hand, risks that are associated with these various experiments, but also it can make calculated decisions to minimize impact of potential failure in the future, and also therefore guarantee better the quality of products and the quality of the production process. And I know that it's easy talking from my side, but we know that the support from management level is very important for having this culture for measurement, but also to implement a successful design of experiments. And we know that that if your management level is not really aware on what is design of experiments or how it can help, or how useful it can be, it's implementing can be hard. And that's mainly also part of this webinar, is to show where are those adoption barriers, because we kind of hope that it might give you the words to also talk to maybe your management level, to give them to show them what are the benefits of doing this structured approach of data acquisition, instead of just doing either one factor at a time, or just doing experiments without a structured approach. And the reason why it's sometimes very difficult also to convince management, and Peter already touched upon the topic for a very brief time, is that design of experiments is perceived to be very expensive. And I have here the picture of an iceberg, is because most of the time what we see with traditional data collecting approaches, such as one factor at a time, or just gut feeling kind of this experimentation, is that you see the tip of the iceberg, but actually the cost is hidden under the waterline. It's actually pushed way further into production, and it sometimes ends then somewhere with quality assurance, because somewhere something goes wrong, but nobody actually knows what is going wrong in the process. And then then you still have to go find what happened in that in the production, or in the composition of the product. But if you do design of experiments, you see the full costs. And the thing is that if you have the benefit of actually having that full cost, is that you know what you that it's more transparent, and that you can actually account for it, and that you can really make a budget it. And it may feel uncomfortable at first for a manager to approve this maybe a cost that looks way bigger than when you would do one factor at a time. But if you explain that this way, you can see the full cost of actually the full process, and that it has that benefit of risk management and quality assurance management, then and you can explain that this avoids that having bad upstream decisions will be sent downstream. It may be a part where you can convince indeed managers to actually do design of experiments, and maybe then they see that although it looks like it's more expensive, it's actually keeping them from making bad decisions that are being pushed downstreams, and then might cost way more than it does upfront. And then, as a last point, we're onto software. I think, we know that software for design of experiments is not always very easy to use, but I think Peter can elaborate a little bit more on that.
Sure. I think we cannot deny that design of experiment software has made huge leaps forward in the last 2 decades. The flexible technology called optimal design of experiments has become available in the last 20 years. And advanced DoEs, which I will name here, split plot designs, strict plot designs, split plot designs, they are all available now to cope with real-life situations where the logistics of the experiment is somewhat hard and cumbersome. So all these designs have a reason for existence, and we can nicely create them with software. The problem is that to do that properly, you need to understand difficult jargon. You need to have great insight. So I think to make DOE really accessible, software should make another leap forward to make these useful designs available in an easy way for the average user. And by that, I mean the average engineer, the average scientist who doesn't have a degree in statistics. And I think artificial intelligence can help there quite a lot to make the translation from the actual needs of the engineer and the scientist, including all logistical considerations in the experiment. So I think AI can help to provide the software with the right input so that the right DOE comes out of the software without jargon, without, requiring every engineer and scientist to become a statistician. So I think that would be a great leap forward as well. Having said that, as an academic researcher in design of experiments, I would also like that design of experiment software would have the most advanced DOEs always available for the users. But as I said, preferably in a way that the average engineer and scientist can use them whenever these designs are needed.
Thank you, Peter, for your valuable contribution. And this concludes our webinar. Thank you so much for being here. And if you would need more information after the webinar, please feel free to reach out or visit our website www.fx.app. Thank you so much and hope to see you next time.